Hello, everyone. So, very nice to speak in front of such an amazing crowd here. And I think it was an amazing 3 days, and I realized that I'm the only thing between you and beers. So I promise you it will be something, or it will be worth it. But first of all, I want to take the opportunity to thank all of the people who were making this possible the last couple of days. So all of the people behind the scenes and the crew and the staff and everything. Give a huge round of applause to them, please. So let's start with my topic, testing and test-driven development and how we can write good tests. But because this is the last talk of today, I wanted to do a couple of special things. So what I do, spoiler alert, I will talk about the most important aspect of how to write good tests right at the beginning. So the most important part when testing is tests first. So let's try something. So I say tests, you say first, and say it loud. So tests, first. Great. Another time, tests. Awesome. Okay, so you learned the most important thing first, but now let's talk why should we even test? Why should we care to write good tests, and why are bad tests so bad? So in my days, I wrote a couple or a lot of bad tests, actually. So that's how I learned that writing bad tests doesn't deliver on all the promises that people who talk about testing like me say we get from testing, because we wrote a lot of tests and we had end-to-end tests and component tests, but still we faced a lot of problems, and sometimes it was even worse than without the tests. So I really realized how important it is to write really good tests, and I learned how to actually write good tests. So why do we want to write good tests? First of all, good tests allow us to refactor our code with confidence. So this means whenever you make a change, you can run your tests and you know that everything still works. So you can make changes very freely to your code and improve your code that way. Another important thing is that tests enable us to write code faster, or even to write better code faster, because thanks to automated tests, we have faster feedback loops, and those faster feedback loops enable us to write better code faster. And last but not least, if we want to, we can even deploy on Fridays if we have good tests in place. But you still don't have to if you don't want to. OK, so I said the phrase good tests a couple of times. But how do we actually write good tests? And luckily, there are only two important aspects when it comes to writing good tests. And the first one we already learned at the beginning. So write your tests first. But the second one is we want to decouple all the things. So let's start with what I mean with all the things. The first thing when it comes to decoupling, when we want to write better tests, is we want to decouple our tests from the test framework we are using. So now you might think, why do we want to decouple our tests from the framework? And there are a couple of benefits. So mostly it's about reducing the cost of change. So you saw Debbie yesterday, and Debbie presented Playwright, and she did a very good job at selling the benefits of Playwright. So you might wonder, we have all those tests in Nightwatch or Cypress or something like that. We want to use Playwright now. And if you had decoupled your tests from the framework, it would be a very easy thing to do. So if you decouple your tests from the framework, you only need to change one file, one driver file. So instead of having to touch hundreds of test files and making changes to all those hundreds of tests to swap the framework, you only have to make changes in a single file. So with decoupling from the framework, you can reduce the cost of change. And the second aspect is, thanks to decoupling our tests from the framework, we are able to always use the best tool for the job. So there are test frameworks like Cypress, which have a great user interface and have a watch mode, but Cypress is relatively slow. And then there are other tools like vtest, for example, and vtest is very, very fast. And thanks to decoupling, you can use both. So let's take a look at how this looks in practice. But first of all, I want to show you a little demo application which we are going to test in this presentation. So this is a shopping list, or a very simple application. So we can add bread and we can add butter, for example. And when we are in the shop, we can click on one of those items. So we put the bread in our bag and we want to remove it from the shopping list because we already have it in the bag. Then we can click on it and it's removed. But for now, the remove functionality doesn't work. We will add this later. So this is our simple demo application. And here you see the tests running in Cypress. So here you can see, first of all, we have a very simple test that only tests that we list all the active items in our shopping list. And then we have a more useful test that tests that we are able to add items into our shopping or to our shopping list. And you already can see the benefits of Cypress. So we can debug and we have visual feedback and it's awesome. But if you have hundreds or maybe even thousands of tests, it becomes slow at some point. But not so much with v-tests. So thanks to decoupling our tests, and I will show you later how this actually works, we can run the same tests we just ran in Cypress, also in v-test. So by npx v-test run, the same tests just ran in v-test. And if you have like thousands of tests, then it also is very fast. So at my last talk, I focused only on this topic, and I showed how we can run 1,000 tests in a couple of seconds, which take like 30 minutes in Cypress. Okay, so much about the decoupling from the framework, but how can we do it? So, oh, my clicker stopped working. I think I have to focus again. Yep. So here we see a test written with Cypress. So first of all, we have the what we want to test. So it should be able to add new items to our shopping list, what we just saw. And here we use Cypress, so this Cypress object, and to interact with our application. So we visit the home path, then we check, then we input some text into an input field. Then we click on a button, and last but not least, we check if the item was actually added to our shopping list. But we do this, and we've coupled this to Cypress because you see this CY object. But instead, we can decouple it by injecting a driver into our test. So here you see in the first line, we inject a driver object into the test callback function. And thanks to this, we can now use this generic driver to interact with the application. So here we see basically the same as before, visit, get, and check if it exists, but now with a generic driver. So we can now inject any test framework driver we want. This driver can be an implementation of a Playwright driver, of a Cypress driver, or even a v-test driver, like you saw in the example previously. So much for decoupling from the framework for end-to-end tests. But also for component tests, this is also interesting, but it's not, you don't have to have a driver like with the end-to-end tests, but we can wrap all our test methods inside a utility module, for example. So here we see we import expect, it, and mount not from v-test, for example, or from jest, but from our own utility function. And yesterday you heard Evan talking about migrating the whole Vue test cases from jest to v-test. And he said he wrote a script to do it, but if the Vue tests would have used their own wrapping utility function, then it would be only a matter of changing this one file instead of having to write the script or something like that, which is less work. But as I said, for component tests, this aspect is not that important. Okay, so much for decoupling from the framework to reduce risk and reduce the cost of change. So whenever a new test framework is released or the one we are using is not maintained anymore, we can quickly change because we have decoupled our tests from the framework. The second very important aspect when it comes to decoupling is from implementation details. And luckily, Debbie already talked about this yesterday, so I can just reuse her slide. So she said we should test user visible behavior instead of implementation details like names of functions and, for example, CSS classes. So here we have, in this test example, we see we coupled our test to CSS selectors. So here we have the item input selector and the add item button selector and so on. But this is a bad thing because whenever some developer makes changes to the styling or removes a class or changes the name or something like that, then our tests break. And not only one test breaks, but possibly dozens of tests. And that's not a good thing. So we want to decouple our tests from those implementation details. And how we can do it? Debbie already said this yesterday again. So we can select user-facing attributes with semantic selector methods like getByRole in this example. So if we take a look at our test, now this test is improved by using those semantic selectors. So for example, find by label text. And now you can read the test like a real user would interact with your application. So a real user would not look for some CSS selector, obviously, but they look for an input field with a certain label. So a real user who wants to add some items to the shopping list looks for an input field with the label, with a label that signals to him or her that they can enter the item they want to add to the shopping list. So in this case, bread, for example. So they look for an input field with a label. And the same is true when they want to submit this data. Then they look for a button that they can click so to submit the item to the shopping list. And last but not least, when the item was added to the shopping list, we want to make sure that it's actually visually somewhere on the screen. We can do this with this find by text method. And one thing I disagree with Debbie, she yesterday said that we should learn accessibility, or you don't have to learn accessibility, but I disagree. All of you have to learn accessibility. And by using those methods, we make sure that when we implement this functionality, we actually use a button, and then it's accessible to everybody. If we use a div, it wouldn't be accessible. OK, so much for end-to-end tests again. And now for component tests, this is even more important. So when we talk about component tests, we absolutely want to make sure to don't test implementation details. And we see this with this test here already in the description, where we say it should emit a delete event when executing the delete method. And this is something you absolutely should not do. So here we see we rely on the implementation detail that in our component there is a delete method. Luckily, with Vue's script setup, that's not that easy anymore to do, but it's a great example to demonstrate this anti-pattern. So instead, we should refactor this component. But why is it such a bad thing to rely on implementation details like this delete method? So whenever you want to refactor your code, so whenever you want to change how your component works, so you want to, instead of triggering this delete method, you maybe emit this event some other way. You don't need a method anymore. You trigger the event directly in the event handler maybe, or stuff like that. So you want to be free to refactor your component, but by coupling your test to those implementation details, you can't refactor your component freely anymore, and we should avoid this. And how can we do this? In a similar way that we already saw with our end-to-end tests. In this case, we are using the testing library. So if you don't know the testing library, Google for it. It's really a great library to write better component tests, in my opinion, because it forces you to do the right thing. And we can see this here by changing the text or the description already. We say it should emit a delete event when clicking the delete button. So now we are thinking, or we are looking at our component from the perspective of a real user interacting with the component, opposed to thinking about the code that's inside of our component. And then we can create a user with the user event setup method we get from the testing library, and we can use this user object to simulate a click event, for example. In this case, we want to click on a button, and we use the same semantic selector method, find by role, to actually select the button and click it, and then we expect our component to emit a certain event, in this case, a delete event. So this was about decoupling from implementation details, and why is it so important to decouple our tests from implementation details? Because we want to be able to, at all times, freely refactor our application and change our code. And if we have coupled our tests to implementation details of the code, we can't make those changes. So our tests block us from making changes or refactoring our code. And the last aspect in which we want to decouple our tests is from the user interface. And this might sound a little abstract to you. So how and why should we decouple our tests from the user interface? And for this, I want to show you first what I even mean by coupling our tests to the user interface. So if we take a look at our test again, then we see, for example, the first command, the visit, we've coupled our test to the user interface detail that we are testing a web application. Because in a native application, in a native desktop or mobile application, there is no concept of paths, for example. It just doesn't exist. In the next line, we use find by label text. And although in native applications we also have something like labels, but for example, in a voice-controlled application, so in an Amazon Echo application, there is no concept of a label text or an input field. And the same is true for buttons and also text. So again, for voice-controlled applications, there is no concept of text. So this test would not make sense. But why is it important? So for this, we look at an improved version of this test. And the final version with the test, that's the test I'm happy with. So here we see, now we've also decoupled the test from the user interface. We did this by introducing our own domain-specific language. So let's think about a physical shopping list, for example. So if you have a notebook in your hand and you write your shopping list down, there's also a concept of open. So you can open your notebook, for example. There's also a concept of adding an item to this list because you write it down, and the same is true for voice control applications. And also the assertion that we expect the item to be on the list. It's true for like a voice control application and for your physical notebook or for a web application. So by decoupling our test from the user interface, we now have a test that serves as a documentation of how our features of, or how our application or the features of our application are supposed to work from a non-technical point of view. So this is a very simple domain, like the shopping list domain. So to some extent, we are all domain experts in the shopping list domain because we all have written our fair share of shopping lists probably. But imagine you have a more complicated domain like shipping business or accounting business or something like that, and you're writing software for accounting. Then it's much harder for a domain expert to actually understand the specification of your application. And if you have tests like this, every non-technical domain expert can understand this test. So even if you don't know anything about programming, you know what it means to open a shopping list, you know what it means to add an item to a shopping list, and you know what it means to expect that the item is displayed on the list. So by decoupling the tests from the user interface, we have two benefits. First of all, the tests serve as documentation, and we can share them with domain experts, so to show them how we implemented stuff, and they can say, yeah, that's how we expect the feature to behave, and that's correct or not. So imagine showing a test like this to some domain expert. They have no idea what's going on here. But with this one, it's very easy for them to understand it. And as I said, this is a very simplified example. It makes a lot of sense for more complicated stuff like accounting, as I said. So for very complicated domains. Okay, so here we see an example of how this is implemented, this domain-specific language, in this case, domain-specific language for the shopping list domain. We have this add item method and this remove item method, and here we see the second benefit of this decoupling. The add item method actually encapsulates two actions, like entering some text and clicking a button. So we can dry up our tests that way. Imagine you have to add items in dozens of tests, then you can always reuse this one. And as I said, in more complicated examples and more complicated domains, you probably have also more complicated domain methods. So less repetition in your tests that way. So much about decoupling. We want to decouple our tests from the test framework to reduce the cost of change and always use the best tool for the job. We want to decouple our tests from implementation details, so to be able to freely refactor our code. And we want to decouple our tests from the user interface so that our tests serve as documentation and we can dry up our tests a little bit. So that brings us back to the most important aspect, to write specifications or tests first. So why did I cross out tests here? Because if you think about the semantics of a test, then you're testing something that's already there. So for example, you have a finished product and you're testing if it does what you expect it to do, or what it's supposed to do. But with a specification, it's a little bit different, because a specification you usually come up before you produce some physical object or code. So you specify how the code you write is supposed to behave, what it is supposed to do. So I ask you to think more about specifications than about tests. And why do we want to write the tests before the implementation? First of all, it forces us to think about the code, about the public API of our code before we write the code, which is very useful to write better code. Second, we get blazing fast feedback that way, because if we have an automated test in place, then the automated test makes sure that the few lines of code we just wrote do what we expect them to do. And ultimately, what this leads to is that we are able to come up with a better design. So I want to show you a little demo of how this works in practice. So here we see the test for adding a new item, and we now want to add the functionality to remove items. So we say it should be possible to remove an item, like that. And if we want to remove items, there should be items, or there have to be items already in the list that we can remove. So here we have a prepare method where we can prepare the initial state of our application. For this, we need the driver. So we say we want to have active items in our shopping list. Then we open our shopping list, and now we want to remove an item. So we use the remove item method with already specified up here. So here we see the remove item, which is basically just wrapping this find by role button and clicking the item we see in our list. And then we expect item not in list. Then we expect the bread item not to be in our list. So let's start retest in watch mode. As we heard yesterday, watch mode is really awesome for test-driven development. It's, I think, an underrated feature. So here we see a failing test now, as it's supposed to be, because we didn't implement this functionality yet. Now we could start. So we wrote the test. Now we could start writing the implementation. But I want to do a second thing. I want to also add a component test, because I think this is a great time to also add a component test. Why? Because if we look at the implementation of the current functionality, we see we have a shopping list component here, which is responsible for rendering the list items, so only the list items. And our shopping list app item is responsible for managing the state, so adding items, removing items, and stuff like that. So this shopping list component has to communicate with our parent component to make sure that we can trigger the remove action. So I think it's a great time to add a component test for this interaction between those two components. And I already prepared a component test for this, and I won't write it live because I already know that I'm a little over time, so I just use what is already there, but I can explain it very briefly. So here we see this user object, which we can use to trigger user events. We prepare or render our component with one item in it, so that there is an item that we can click. Then we click the first item in the list, the bread item, and then we expect that the remove event was emitted. And here we already see that it forces us to think about the public API of our component first. So it forces us to think about how we want to name this method we emit. And it forces us about what value we want to emit. In this case, we emit the ID of the component. So because we could emit the name or the title of the item, or we could emit the whole item object and stuff like that. But because we put ourselves in the shoes of a consumer of this component, it forces us to think about the public API first, and we probably come up with a nice public API that way. So let's implement this. So let's go to the shopping list component, and we already see, or first save this and take a look at our tests, and we see we still have one failing test. I think we have to restart. Now we have two failing tests. So now we want to make them green. And the first problem we see is that find by role button doesn't work because it's a div. And that's a nice thing that it tells us this, so we have to change this to button. And if we change this to button, the test will still fail, but it will fail at a different place. So it says, yeah, the element should not exist, or this is the wrong test. It says it should emit a remove event, but it doesn't because we didn't implement it yet. So let's add a click handler here and say emit remove. And it will still fail, but again at a different place. Now it says it is expected the 1 as value, but we got undefined, so we also add the item ID here. And now we only have one failing test, which is our end-to-end test. And it still fails because now we only emit the remove event, but we don't do anything with it. So let's go to the app and change this. So listen to the remove event and say we already have an add item method, so let's add an remove item method. Makes sense. And copy this one, change the name, say this is not a remove item method, and we get the item ID, oh, it's a number, as a param, and then from the shopping list repository, we get an update method. Let's import it. And let's see what it expects. It expects an ID, and then we can provide some data to change the state. And if we change the state to inactive, then it will remove the item from our shopping list. So let's remove this and add the item ID here. Then we update this, we can reuse this, then we update the value of the items from the local storage. Basically, we could use some more sophisticated logic here, but for now, that's fine. And if we save this, it still doesn't work because it's active. So let's, I'm not quite sure, is it inactive? It's inactive, oh. It's inactive, yeah. So just like that, the test is green and everything works. Thanks. And you did see we get feedback in milliseconds, not seconds or minutes or something like that, in milliseconds. Imagine you using manual testing, so you open the browser and check if it works or not, and check the console or whatever, and that way we get feedback very fast. And you now might think, yeah, but maybe it doesn't work because only the test works, but it doesn't really work. But now we can run the tests again, and we see it works also in Chrome, and we can open the application, and we can click, and it works. Perfect. So, okay. So I'm running very late, sorry for that, but you get to your beers, I promise you. Okay, I gift you all beers because I can do it. It is free, as we learned. So, It's so easy to get applause. Just mention beers. It's amazing. So, what did we learn? Decouple all the things and tests. Nice one. And enjoy your work.